Welcome to my YouTube channel. Today I'm going to actually do more examples on ionic equations, but this time I'm going to focus on two ions specifically, and that's going to be hydroxide and proton. Okay, proton is H plus, hydroxide is OH minus. When they do react in most of the apparent acids and bases, we have two sorts of acids and bases. Acids and bases that we say apparent acid and base, those are the ones that we could literally see in their formula, H or OH. So that's going to be a well indication that we have a base or we have an acid. When they join together, actually you're going to have, let me just get one of these. If these two ions join together in a bond like this, it would give you water, okay, H2O. And that's what actually we're going to do today. With apparent acids and bases, we're going to get this. Okay, so let's go on and talk about acid-base reactions, and I'm going to do ionic equations for acid-base reactions. Okay, let's do some simple example first and then move on to other more harder examples. NaOH plus HNO3 is going to give you what? So what is going to be formed is a salt. So there's a rule that says put out the cation from your acid, from your base, and the anion, an ion from your acid, and make a salt with that. Okay, so the anion here is NO3 minus, and the cation is Na plus. Na plus and followed by NO3 minus. Because the charges are equivalent, I'm not going to actually do any underscripts. If the charges are not going to be equal, then I have to do indices, okay, by swapping the charges. Because the charge is +1 here and -1 here, there's no need to do underscripts or parentheses or underscripts for NO3. Okay, I then put 1 here for this and go back to this. If I have 1 nitrite, so 1 HNO3, and if I have 1 sodium, also 1 sodium here. Okay, and then you could see how many OH minuses you have. You have 1 OH minus and 1 H plus. That gives you 1 H2O. Okay, and that is the overall reaction. I can get rid of these 1 coefficients because it's balanced. We know that it's balanced. Now I'm going to write down the cations and anions. So H plus, NO3 minus, giving you Na plus, NO3 minus, and H2O. Okay. There's just now, let's go to the numbers. I have one sodium cation, 1 hydroxide, 1 proton, 1 nitrate, also 1 sodium and 1 nitrate here, and 1 H2O. So if I just get rid of, and H2O is the one that's going to be liquid. Again, I don't put aqueous here, but you should notice that when you have acid-base reaction, if you have H2O, it's the one that's going to be liquid. But I will also give it to you, or it's mostly given in an equation, that H2O is the one that you can't dissociate. Okay, so this one and this, oh my bad, sorry about this, I'll just fix it real quick. I just did the wrong one. Sodium and nitrate are the spectators. They happen at the frame in both sides of the equation. And as I do so, I could say OH minus and H plus is going to give me H2O. Just like the connection that I did at the very beginning of the video, joining these two H plus and OH minus to give H2O. Anytime you do the net ionic equation for apparent acid-base reaction, you should get this equation to actually form H2O. Okay, let's move on to yet another example of this. See how many of these examples I could do. HNO3 plus calcium OH2, giving you calcium nitrate and H2O. Okay, actually we're going to predict this. So again, the cation from the base, which is calcium double plus, and the anion from the acid, which is NO3 minus. So I go calcium NO3, and I swap the charges. The charge for calcium is +2, so I put 2 here. The charge for nitrate is just 1, so I could ignore it. Okay, so that's how I move this. And if I assume one of this, it's going to be one calcium, one calcium. If it's 1, it means 1 times 2, so 2 nitrates, 2 nitrates. This guy would have 2 protons, and this guy has 2 hydroxide, so I'm going to get 2 H2Os as well. Okay, let's just write down the total ionic. Okay, now I have 2 H pluses, 2 nitrates, 1 calcium and 2 OH minuses. Also here 2 nitrates and 1 calcium. So you could see that the 2 nitrates here and 1 calcium double plus is going to be the same appearing on both sides. And again, you have for your net ionic some H plus and some OH minus, the same exact amount joining together to give you 2 H2O. These numbers are going to be always the same. The same exact number of protons they'll join up with the same number of hydroxides to give you the same number of water molecules. So that's what you get. And as I move on, you do H2SO4 plus LaOH to give you, again, cation is lithium plus, lithium is group 1, and anion from my acid is SO4 double minus. So I go LiSO4 plus, and Li, the charge for sulfate is 2 minus, so it's go 2 here. The charge for Li is plus, so I don't need a parenthesis and a 1 because we don't write 1 in chemistry. If I assume that this is 1, it would be 2 lithiums, so 2 of lithiums here, and it would also be 1 sulfate, so that would be fine. So 2 OH minuses, 2 H pluses, 2 H2Os, that's the reaction. Now let's go on and put down the ionic equation. H plus, SO4 double minus, Li plus, OH minus, Li plus, SO4 double minus, H2O. 2 H2Os, and let's take care of the number of ions. 2 H pluses, 1 sulfate, 2 Li pluses, 2 OH minuses, 2 Li pluses, and that's that, 1 sulfate. Okay, the spectators are the 2 lithium pluses and the sulfate. Okay, SO4 double minus, and the rest then becomes 2H plus and 2 OH minuses, giving you 2 H2O. Okay, so that's that. Let's move on to yet another example. And as I do so, I'm moving on to latent functionality, where you can't see the apparent H plus or OH minuses. Okay, so you're going to take whatever you have apparent, NH4I, ammonium iodide plus KOH. A given will be given to you, and that's the one that's going to coming from the latent. This you can't guess, so I'm going to give it to you. Or the equation will just simply give it to you. So you're going to discern the apparent base or acid. Here we have an apparent base, so the other one should be our acid. Okay, so we go for the anion from the acid, which is I minus. Again, the acid doesn't have H in it explicitly because this is an ammonium, NH4 plus, and then this is the cation from the base, K plus, so that's Ki, and you're going to say, if we assume one of this, it would be one of this, and also one iodine, so that would be fine. Okay, and that was a given, so that would have we should be already balanced. Okay, so now let's say write down the ions. NH4 plus, I minus, K plus, OH minus, giving you K plus, I minus, NH3. And also, if you have one OH minus, I have to add the number of waters myself. So NH3 and 1 H2O. So H2O and NH3. So when you write that down, you should note that the number of OH minus, because you don't feed literally the number of protons here, one that tells you that should be one proton is the number of OH minuses, the apparent base. Okay, so there should come one H plus from this thing, the latent functionality, to actually make one water. Okay, so the number of the one that is apparent will give you the number of waters. Okay, so the number of the cations, one ammonium, one iodide, one potassium, one hydroxide, also one potassium, one iodine, iodide, and one water, and NH3 was already given. So the spectators here then becomes the K plus and I minus, and you're going to say that my net ionic is NH4 plus and OH minus, giving me NH3 plus H2O. Again, this is liquid, this is liquid, this, it could be gas or as well. This is aqueous, this is aqueous. I'm not going to write this because it's going to take a lot of time, but I always going to mention what we get. Let's just get this right. Okay, let's now go on to yet another example of latent functionalities. See how much of those latent functionalities I could cover. HClO4 K2CO3 giving me two H2Os and CO2. The number of waters where you have latent functionality may sometimes be given, but you could always guess it. Okay, so again, you have a apparent acid, but you have a base that you could actually, that's a latent functionality, so you can't guess this. So the anion from the acid, which is ClO4 minus, and the cation from the base, which is K plus, so you should go with KClO4. The charges are both 1, so we don't need any underscript, neither for scholorate or for potassium. If we took one of these, actually we should go with a half for this. But since we want no fraction, I should take this one as 1 and put 2K. So 2 colorate and 2 colorate are also here. And then I go with 2 protons on my acid, so my number of waters should also be 2. That is already given. You may not have this, but you could actually guess that. Okay, let's now go back, write down the cations. H plus, ClO4 minus, K plus, CO3 double minus, K plus, ClO4 minus, 2H2O, and the CO2. My bad if it's so small there. So 2H pluses, 2 ClO4 minuses, 2 potassiums, 1 carbonate, 2 potassiums here, and 2 ClO4 minuses. The rest are balanced previously. So the colorates, 2 of them, and the potassium are the same both in the reactant and product side, so it becomes 2H plus and CO3 double minus, giving you 2H2O and CO2. Again, these are liquid. This CO2 is a gas, and it should also be a given. You don't need to guess this. This one is going to the one that could be liquid. Also, this one will be given, but you need to write that down. I don't write it down because of the time. Let's move on to yet another example. Let me see if I use my other colored marker. I could make it a little bit convenient. Okay, so let's move on to yet another example. NH4 2SO4 sulfate plus calcium hydroxide, giving me 2NH3 at the very last, and I need to guess the others. So the acid is not, the base is an apparent one, so I have OH minuses, but the acid is not, so I'm going to get the cation from my base, which is calcium, and the anion from my acid, that is sulfate. And because calcium is calcium double plus, sulfate is SO4 double minus, I don't need underscript for neither of them. Okay, so calcium sulfate would be my base, and if I just assume 1 here, it would be 1 calcium, 1 sulfate, so 1 sulfate. So I don't need anything extra. If there's 2 OH minuses, I get 2 H2Os. I can't see the number of my protons, but it should be 2. Let's do the cations and anions in total ion. Calcium double plus, OH minus. Again, calcium double plus, SO4 double minus. 2 H2Os and 2 NH3. Okay. Now I have count the number 2 ammoniums, 1 sulfate, 1 calcium, 2 hydroxates, 1 calcium, 1 sulfate, 2 H2O, and 2 NH3. And the ones that are spectators are calcium and sulfate. Okay, net ionic then becomes 2NH4 plus and 2OH minus, giving me 2H2O and 2NH3. So that's how you do it. That's the other example. Let's move on. I have more examples here to do so that you could clearly get the hang of these kind of problems. Let's move on. My other example is magnesium bicarbonate plus HBr, giving me again 2H2O and 2CO2. Okay, so I just have to guess my fault, and then the number of water is simply given. The acid is apparent, the base is not. The acid is HBr, so the anion from the acid is Br. The cation from the base is magnesium. Magnesium is magnesium double plus, so I go with an indice for Br. Br is just -1, so I don't need any indice, so that's 1 for magnesium. If I assume 1 here, that would be 1 magnesium. If I assume 1, it would be 2 bromine, so 2 HBr as well. Let's now we'll put down all the ions in the total ionic. Magnesium double plus, again from the periodic table. Bicarbonate, H plus, Br minus. Magnesium double plus again, Br minus again. 2 H2Os and 2 CO2. Let's do the pluses between them and then judge the numbers. I have 1 magnesium, 2 bicarbonates, 2 H pluses, 2 Br minuses, 1 magnesium, 2 Br minuses, and those are balanced by themselves. So the 2 Br minuses and the magnesium double plus both are they both are appear on both sides of the reaction, so those are the spectators. If I just ignore them, the 2 bicarbonate and 2 H plus are going to give me 2 H2O and CO2, 2 CO2. So that's net ionic. Okay, let's move on to 2 more examples, and I would wrap it up with 2 more examples here. Let's use the other color. Let's see if it has a better look for so right now. K2O plus H2SO4, giving me K2SO4 and giving me H2O. Okay, so H2O was given. You have an apparent acid. The base is a latent one. Okay, how do you know this is a base? Because this one is an acid, so the other one should be a base. So you have the SO4, the anion from the acid, and the K, the cation from the base. K is just +1 because it's group 1, so sulfate doesn't need any underscript. SO4 is double minus, so K needs a 2 underscripts. If I assume a 1 here, that would be 1, making for the 2 potassiums that each has. And if it's only 1 sulfate, this should be 1 sulfate, and the number of water molecules should be 2, because there's 2 protons in my apparent acid. Remember, if you have one apparent acid or one apparent base in any reaction, the number of protons in that acid or the number of OH minuses in that base determines the number of waters. Let's just do the cations and anions. H plus, SO4 double minus, K plus, SO4 double minus, H2O, and 2 of it. Okay, 2 potassiums, 1 oxide, 2 H plus, 1 sulfate, 2 K pluses, 1 sulfate, and that's all. So now let's move on and say this is my sulfate, this is my K plus, sulfate and K plus, those are the spectators. And if I just write down the reaction, the oxide plus 2 H pluses will give me 2 H2O. Oh, actually 1 H2O, my bad. 1 H2O. I didn't know how I did make that, but for this one, it was already given, and I will tell you that it's 1. Okay, and I will also give it to you in a hint that in this special case, your anion is going to consume 2 of those. So that's a given, you don't have to guess that. And that would be your your final net ionic equation for this one. Let's also do my final example here before I wrap up, and that's going to be H3PO4 with LiHSO3 giving me 3 SO2s, and I'm going to guess the cation. This is again like the previous example, a given. You have an apparent acid, so this guy should be the base. The cation from the base is your lithium. The anion from the acid is your phosphate. So you go about the charge. The charge of your phosphate is 3, so underscript 3 for your lithium. The charge of your lithium is +1, so you don't need parentheses because that's a 1 for your phosphate. Let's go about the cations and anions. Phosphate, lithium, HSO3 should be minus because lithium is +1. Again, you have lithium plus, phosphate, and SO2, the 3 of it. Let's just judge the numbers. 3 protons here, 1 phosphate. Let's see, this guy should have a 3 because when we say one of these 3 lithiums, and if we say, yeah, so that's the only thing we need to do, the 3 over here. So it's 3 lithiums and also 3 of this. The 3 lithiums also here, it's 3, and phosphate is just 1. So now let's go on and judge. This is my phosphate and lithium. My bad, this guy is 3 minus. Phosphate and also 3 lithium pluses. So let's just, these are the spectators on both sides. So that's 3H plus and 3HSO3 minus, giving you SO3, 3 of it. And then we didn't judge the number of H2Os. Again, on my acid, I have 3 H pluses, so there should be 3 H2O. Also, I have 3 H2O here, and I add 3 H2O here as well. Okay, so that would be the net ionic. 3 of this and 3 of this, giving you 3 H2O and 3 SO2. Let's wrap it up with this one here on this video.